In this video, we're going to be discussing this problem on arithmetic sequences in Algebra 1. The problem statement says, a sequence starts off -9, -6, -3, 0, and so on. Determine whether this is an arithmetic or a geometric sequence. Then determine a rule for a sub n, or basically the nth term of the sequence, and find the 81st term of the sequence. So to solve this question, we're going to need to first determine whether this is an arithmetic or geometric sequence. There are two different options here. And before we begin, let's just quickly review the facts here. We know that an arithmetic sequence here, that's one type of sequence, is any sequence with a common difference. And it's very important here, the common difference is essentially the difference between each term in the sequence. How much you change between each term, between one term to the next. And it's going to be the same between any two terms, any consecutive two terms in the entire sequence. So arithmetic equals common, well, it's going to have a common difference. Okay, so in the example here, in this particular sequence, the common difference we know is going to be 3, because the difference between -9 and -6 is 3. So that's our common difference. We can just write down CD equals 3. This also confirms the fact that this is an arithmetic sequence, not a geometric sequence. Because a geometric sequence would have a common ratio, like for example, 2, 4, 8, 16, 32. All the terms are being multiplied by 2, so that ratio would be 2. But we're not multiplying terms here, we only have a common difference. So our CD, or common difference in this case, is 3. So we've answered at least some part of the problem. Now we're going to need to determine a rule for the nth term of this sequence. So we know the formula for finding the nth term of any arithmetic sequence is going to be a, where a is the first term, plus n minus 1, where n is the nth term, times d, where d is the common difference. So we know a and d in this case. The first term is -9. We can fill that in. So it becomes -9 plus n minus 1 times 3. And this right here is our rule for the nth term of the sequence. And this works because that's the general form of the nth term of any arithmetic sequence. So we've got the -9 plus, in parentheses, n minus 1 times 3 as our formula here, as our rule. Now we need to find the 81st term. So all we have to do is plug in the 81 as the value of n. So it becomes -9 plus 81 minus 1 times 3, which is -9 plus 80 times 3, which would then give you -720. Or not yet. Or not -720, because then you're going to be going into the positive zone. So all you have to do from here is evaluate this expression. So -9 plus 80 times 3, and you'd wind up with your final answer. So all you have to do here is first determine whether this is going to be an arithmetic or geometric sequence. Then we find the common difference, because this is an arithmetic and not geometric sequence. We find the common difference by looking to the difference between each of the terms here, -3 and 0, -9 and 6, and so on. And we find the common difference, and then we find the rule for the nth term of the sequence, using the a plus n minus 1 times d general form, plugging in the values for the first term, a, and the common difference, d, and then filling in our formula here, or the rule, using the 81st term to get to our answer of 720. So we've come to the answer to this question using the rules we know about arithmetic sequences. All we had to do here is first determine the type of sequence, then the common difference, then find a rule, and then plug in numbers into the rule to get to a final answer. So this was a problem about arithmetic sequences and series in Algebra 1.